All right, and with that then, welcome again. Very happy that so many of you made it today. So many of our customers are facing the challenge that there is more and more functionality to test in less and less time. If this sounds familiar to you, you're in very good company. These are all the companies that signed up to this workshop up to last week. And what we can see here is that this is not only a topic in one industry, in one development process, with one development process, or with one programming language or something like that, but is a cross-cutting issue across all these dimensions. Today, we'd like to show you how you can tackle this with the help of test gap analysis. My name is Thomas. I'm part of the test intelligence team here at CQSE for about 5 years now. And in this team, we are helping our customers to set up, amongst others, test gap analysis and to use it effectively in practice. I'll show you today in the first part, the motivation and theory behind test gap analysis. In the second part, I'll show some practical examples how our customers are using it. In the third part, my colleague Stefan will take over and show you everything I've shown you in theory in a practical example in a live demo. And then in the fourth and last part, I'll take over again and show you a study we did together with one of our customers to analyze the cost-benefit ratio of test gap analysis. Before we dive into the topic, a few more words to our company, to CQSE, because I'm not sure if everyone knows us that well already. CQSE was founded around 15 years ago as a spin-off of the Technical University in Munich. And so it's a little surprising that our headquarters is also here in Munich. By now, we have a variety of offices and home office locations all across Germany. So if you're located in Germany, the chance is quite high that someone of us is sitting near you right now. We also have an office in Silicon Valley to help our customers overseas. We are in total 61 employees, 57 of which have a background in computer science, and 23 even have a PhD in a software engineering related topic. We as a company are developing TeamScale. This is a software analysis tool which does, amongst others, test gap analysis, and this will exactly be the focus topic for today. So let's jump in. As testers, you're probably very familiar with the problem that there is more and more functionality to test in less and less time, because like the successful software grows over time, so there are more features which we can test, should test, and the release cycles are most of the time, in most contexts, getting shorter and shorter, and thus we have more to test in less time. And of course, we want to test as effectively as possible, so to find as many bugs as possible in the software. So we need some means to focus our testing efforts. There's a whole field of research asking itself this question, and this field is called defect prediction. So essentially, you give me a software system and I tell you where all the bugs are in. In practice, of course, this is not, you cannot answer this question perfectly, because otherwise testing would be rather straightforward. And as you surely know, most of the time it isn't. But there's one main takeaway from this field of research, and that's most bugs are hiding in the areas that were recently changed. Now you might laugh and say, yeah, well, I already knew that for 10 years. Why did I knew this research? And this also fits with our experience with our customers. So most companies are already testing in a way to cover their recent changes. So that's not surprising. Nevertheless, it's of course also nice to have this confirmed by research. Although many companies already use this approach, there's one main problem in the implementation of it. And that's that most companies are relying on information from their issue tracker to see what has actually changed. And this has two problems. The first one I'd like to show you on an example from our own development process, from our own issue tracker. So here you can see all the systems we have used as an issue tracker. Some of you might be familiar with for you. So at the start, we used just a simple whiteboard moving cards around. Then at some point, we migrated to Bugzilla because like a whiteboard doesn't scale with more people at some point, of course. And but right now we are using Jira. And probably most of you are also using Jira, I'd guess. And what we did is we, at some point in time, we categorized our tickets into 4 different categories. So the right most category right here, the perfective tickets, these are the feature tickets. The second to the right category, the corrective tickets, these are the bug tickets. And for those 2 categories, it's usually quite straightforward what needs to be tested. So for feature ticket, the description usually states something like, my software should now be able to do X. And then you can write your test in a way, you can execute a test in a way that just tests that X is actually possible now. For bug tickets, it's similar. You have something like software behaves like A, but should behave like B. And then you can just test more or less straightforwardly that it actually behaves like B now and not like A anymore. It's a bit more difficult for the other 2 categories though. So preventive tickets are maintenance tickets. So essentially, these are related to changes you're already doing in advance to make bug fixes and feature implementations more easy in the future. And adaptive tickets are the ones that need to be implemented because some library or something you're using changes, and you also need to do some adaptations in your own code for that. And for these 2 categories, it's often not that clear what actually needs to be tested because either the descriptions are quite technical and hard to understand, or like it just states that like the database driver needs to be changed, and this affects a whole lot. So essentially all areas of the code, and large areas are affected, but it isn't really, you can't really tell that from the issue description alone. So that's difficult to see then what needs to be tested for these 2 categories. So that's the first problem when relying on issue information to see what has changed for the software. The second one is that often not all changes are actually documented in the issue tracker. And this can happen on different scales. So on a very small scale, for example, a developer is working on a feature ticket and they notice that in the code they are currently touching or adjacent to that, there's a small bug in there and it's fixed within seconds. So it's way more effort to create a ticket and do all the process and so on, and like a separate feature branch. It can just be fixed in a second. So they just do it in the context of the current ticket. And usually this small fix then is not documented in the feature ticket, which also makes some sort of sense because the fix has nothing actually to do with the feature. So that's on a very, very, very small scale. On a larger scale, we also saw at a company that they had so many tickets, they needed to categorize them into different priorities. And the management told the developers they were only allowed to work on the top 2 priorities. Now they also had a customer, support or customer success team. And one of the people in there talked to their customers and promised a certain feature for the next release would be implemented. They already knew that this feature wouldn't make it to the top 2 priorities. So they never created a ticket for it, but instead talked to one of their developer friends and asked them to just implement it aside of the usual process. And thus, this feature never made it into the issue tracker at all. And maybe the developer tested it with some unit tests, but if you have like test managers writing tests based on the issue description, this whole test step would be completely missing. So these are the 2 extremes in terms of the scale of this, that not all changes are actually documented. And now you might say, yeah, well, how much could this actually affect? Like when a developer changes one line, that happens only every so often. And the other extreme, that usually doesn't happen at most companies. So how big can this issue actually be? And that's a valid question. And we actually also, of course, asked ourselves this question. And so we did a study together with MunichRE back in 2013, so before we had test gap analysis actually, where we looked at one of their C# systems for 2 releases. And for both releases, we checked how much of the code changed and how many of these changes remained untested. What's important to note here is that MunichRE already had back then a quite structured test process. So they actually had test managers writing tests on the issue descriptions, and these tests were then executed by manual testers to cover them, to test them, to execute them. So we looked at the 2 releases and found out that coincidentally for both releases, roughly the same amount of code was newly added or changed. And for the first release, 50% of these changes remained uncovered. And in the second release, 60% remained uncovered. And of course, this was quite surprising to MunichRE because, as I said, they already had a quite structured approach to testing there. We then also looked at another thing, namely how much likely it is that there are bugs in production that appear in production in the untested changes compared to the tested changes, and found out that the likelihood of bugs is 5 times higher in the untested changes. And this is also not too surprising, I guess, because if you don't run through your code, if you don't test your changes, you have no chance of finding a bug in there, and therefore all the bugs that are located in there just slip through. And so the number here is essentially then 5 times higher. As I said, we did the study back in 2013, so before we had test gap analysis. And thus we're only able to do this analysis retrospectively. So after MunichRE already released their software here. And they told us, well, that's very nice to know after the fact. We should do better, but it would have even been better if we knew that before we did the releases. And that was the spark from which test gap analysis was developed from. So we did that together with MunichRE. So what does test gap analysis do? Test gap analysis takes 2 sources of information. On the one hand side, we are taking the changes from the version control system. So we don't rely on the proxy issues anymore, but directly look at what has actually changed in the code itself. So nothing is able to slip through anymore. On the other side, we take the information what has already been executed by your tests, and then we combine these 2 sources of information to see which changes have not been covered by any of my tests yet, and thus are most likely to contain bugs. To show this a little bit better, I'd like to introduce a new visualization, and this is called tree maps, or tree map. Every rectangle you can see here corresponds to one component in a software system. The bigger the component is in terms of lines of code, the bigger the rectangle is here too. Now we can also go down one level. So now we are on file level, and every rectangle with a black border right now is one file, and all the files within one component are still inside these white borders. And the size metric still holds here. So the bigger the file is, the bigger the rectangle with the black border is too here. And we go down one more level, and now we are on method level, and that's the level task gap analysis is actually working on. Now, we've used the two spatial dimensions of our monitors. So we have one dimension left, and that's the color. So in the first step, we are highlighting every method that was adapted since a certain baseline in a color here. So as a baseline, I'll just be using since the last release as an example here. Everything in gray are the methods that remained unchanged. So no high risk of bugs in there. The orange methods are the methods that already existed at the last release, but were changed. And the red methods are the ones that were newly introduced. Then we can do the same for the execution information. So we color everything in green, every method in green that has been executed in one of my tests. And this we do for both automated tests and manual tests. And then if we combine those two sources of information together, we get an image like this, where all the unchanged methods are still gray, because again, these are the low risk areas, and all the changed areas are now colorful again. Green here means these were either changed or newly added, but already covered by one of my tests. So also not that likely that there are bugs in there. And in orange, the ones that were changed since the last release and not covered, and red, the ones that were newly introduced and not covered. And the orange and red ones are exactly the areas where the likelihood of bugs is the highest, and therefore where we should put our focus onto. So what do I do with this information as a tester, test manager, or developer? Well, I look at this tree map and see that there are larger areas of code that have not been tested. So I write new test cases for these functionalities. I execute the test cases, which will again result in new execution information. And this is fed back into task gap analysis again. And therefore, you have a new image of which areas still remain uncovered after executing your new test cases. And you can do this feedback loop as long as you like, until you're confident enough that you can do your release, which essentially means that there are no important test gaps anymore. Note, our goal is explicitly here not to get 100% change coverage. You can, but it's not needed because there are valid reasons why you might not want to test or need to test some of your changes. For example, if you're already preparing some functionality for the next release that's not reachable from the UI yet, there's no need to test it right now. Secondly, even if you had 100% change coverage, this would still be no guarantee that there are no bugs in your code. But that's not a limitation of task gap analysis, but of testing, because we can only find bugs with testing and never prove the absence of them. You certainly know that. All right. Few words to the technical setup. I already told you at the start that the tool which is executing task gap analysis for us is called TeamScale. TeamScale especially compared to other tools, doesn't run in the build, but is its own server application, which directly connects to the version control system. So for example, your Git server. And every time you push a commit to your version control system, TeamScale will notice that in a matter of seconds, maybe minutes, and analyze the changes that are in there in this commit. So you'll always have an up-to-date view on your changes in the code base. So that's the one side of test gap analysis, the one source of input. The other one we need is the execution information from the test systems. And how you get that is you install a tool, which are called coverage profilers, which essentially listen on the test system which code is being executed by the tests, and writes a report, which writes a report in the end. So these reports typically look something like this. So it states that in file A, lines 10, 11, and 12 are covered, for example. And this information is then uploaded to TeamScale as well. We calculate which methods are tested with this information and map it back to the changes from the version control system. And then in the end, we get all the untested changes. I'd like to emphasize again, this coverage collection, this execution information collection, we cannot only do for unit tests, but for all test stages. So for component test, integration test, system test, you name it. And it also doesn't matter if these test stages are automated or if we are talking about manual tests. And once you have all these different coverage information, execution informations, you can also do an aggregation in TeamScale and so see everything in one picture. All right. Before getting into the second part here, into the practical examples, are there any questions already?
So can I just blurt it out? So my question is, would you say that test gap analysis is like, does you help more when you have a lower test coverage? Because when you say like you have 100 test coverage per se, then it doesn't really give you any benefit, right? Or is there some threshold which coverage makes it sense to use test gap analysis and when not?
Essentially, I find it hard to put a threshold value on that because it always depends on if the test gaps you do have are meaningful or not, are important or not. So it's hard to put a general thought, a general guideline, what like if you have below 50% changes test, then you need to do test gap analysis or something like that. So this always depends on the context. To answer your first question, so if you have 100% coverage, is it still worth doing test gap analysis? That kind of depends as well. So if you have 100% test coverage already, then we are talking about something like unit tests. But it's you might still have different levels of test, end-to-end test, system tests, and so on. And these tests are finding different bugs compared to unit tests. So it might still be worth doing test gap analysis for these test stages, because usually for the higher level test stages, the coverage is not that high anymore. Does that answer your question sufficiently?
Yeah, makes sense. Thank you.
Thanks for the question.
Yes, Thomas, as you said, right? So this TeamScale can work with any kind of tests.
Yeah,
you can say like system integration unit or E2E. So
yeah.
I just want to understand, right? So even you mentioned, right, with manual test case also.
Yeah.
I'm just considering, say, manual test case from either JRAT, right? So say in case of E2E, I just want to understand, right? So as you mentioned, this TeamScale tool, along with TeamScale, we use the code coverage tool, say Jacob, right?
Yeah. Yeah.
Yeah. So I just want to understand, right? So in case of that means we have to inject this Jacoco on our server side.
Yeah.
To monitor our execution.
Yeah.
Correct. And then just get the insight from that in the, I can say, in log format or some format, right? That
Exactly.
understand the team scale, and then on that build the report, which gives that exact gap. Correct. That is how it works.
Exactly. It's the same for, so you use the same tools, the same profilers. As you said, for Java, this would be Jacoco. You install on your manual test system, which will listen to the changes similarly to what it would do for unit tests. And you can upload this information to TeamScale. So for TeamScale, it doesn't matter if it's from manual tests. The reports look the same for both. And the tools are the same too, more or less.
Okay. Great. Thanks.
Yeah, thanks for the question.
So there are no questions in the chat currently. Any more questions via audio? Doesn't seem to be the case. Okay.
Then let's continue, I guess.
So Thomas, sorry.
One more. Go ahead.
Yeah. So as you mentioned, right? So we're going to use Jacoco on server side. So so what I know, right? Jacoco also give this code coverage. So whatever the code we covered, right, or tested from our test execution. So
yeah.
Even that helps us to get that gap, right, and to just add the test around that part which is missing from the execution. So on top of that, what team scales actually gives? So say if I am using the Jacoco and if I am using the team scale, so what benefit I will get on top of Jacoco?
On top of Jacoco itself, you mean?
Yeah.
That's a good question, actually. So what Jacoco essentially does, it listens to what areas of the code are executed in your test system. What is missing purely from looking at the Jacoco reports is the change information, right? Because it only listens to the executed method and doesn't have a connection to the version control system. So essentially, you are missing the information where the high risk areas are, because these are exactly where the changes in your source code are. And TeamScale brings the information from the changes and the information from Jacoco together for you to see which areas have the highest risk of containing bugs. So essentially, the ones that changed but have not been covered yet. Does that make sense to you?
Yes, thanks, Thomas. Thanks. Yeah.
All right. Any more questions?
No questions in the chat. You can go on.
Okay. All right. Then I'd like to show you some practical examples of how our customers are using test gap analysis. The first example is a so-called hotfix test. So this is essentially a bug that appeared, say, in production, and that your customers found. So this is only on demand once such a bug appears, and there's usually very little time to do the fix because your customers are already affected. And therefore, you only want to fix the bug and do nothing more. So that the changes are usually quite constrained to a single area of the code. This is an example of an SAP system where such a hotfix was done. So we can see that in total 8 methods are affected by this hotfix. 5 were changed and 3 were newly added. And so what the team did here is do the same process as they always do, and which you should still do, also when using test gap analysis, namely looking at the issue and finding out what the bug fix is about, what the bug was about, and what needs to be tested. So they tested if the software behaved correctly now, and this resulted in this coverage here. So essentially, we see that 4 of the 8 methods were covered by the test. And thus, the tester and the developer talk to each other. The tester asks the developer what all the other 4 methods are. And together they found out that these are some edge cases the developer fixed or saw and fixed, which the tester didn't think about and wasn't explained in the ticket. And so they did another round of testing and closed the remaining test gaps. And then they released, of course, this hotfix right away. Okay, that's rather straightforward. The second example I brought is a so-called release test. So this is done in a very linear development process where you have a long development phase, then a long test phase, and then you do the release, and then you continue this over and over. The specific example I brought today is from MunichRE again, just some years after the study we saw right at the beginning, when they were already using test gap analysis. So they have a test factory, or had a test factory with 5 testers, which tested 6 versions of the system in 2 weeks and 143 test sessions. Why 6 versions of the system? Well, when you're testing, you're finding bugs and you report this to the development team, and they are already fixing the bugs. And then some of the fixes are already deployed to the test system. And every such a version, such a pre-release version, we count as a version right here. So what do the changes look like? Like this. And this picture probably is familiar to you. That's exactly the picture we've already seen before when I explained the tree map visualization. So this is familiar, the execution information as well. And you've also already seen the combined view, the test gap tree map. Now, if you paid close attention already, you might have noticed that there are large areas, large red areas actually, that have not been tested yet. And what we found out here is that there was a communication problem. So essentially, the test factory, the testers, were only told to test existing functionality, so to do regression testing. All the new functionality was supposed to be tested by a test automation project, which turned out didn't finish or didn't make it in time. And so all the new functionality, all the new features remain completely uncovered. Fortunately, at that point, as I said, we had test gap analysis, so MunichRE already knew before. And therefore, they could say, okay, that's way too risky to release every single new feature completely untested. So we want to do another round of testing. And so they postponed their release for another few weeks. But they didn't want to postpone it for a very long time. They already wanted to do the release actually now, right? So they didn't want to get too much delay here. So what they did, instead of doing all the structured processes and again writing test cases, executing them, and so on, is what is called explorative testing, or also sometimes monkey tests. What is this all about? Well, essentially, you're taking all the stakeholders for your software system, so the end users, business people, the requirements engineers, and let them test the functionality they would be using in their daily doing, or for which they have written the requirements in case of the requirements engineers. So in total, they had then 23 testers who tested 8 versions of the system in 2 weeks and 307 test sessions. And we get a new picture for the changes, which is contains some more bug fixes in here. We also get new execution information from these tests they did, of course. And here you can notice even more the changes. And best you can see it here, because you see that most of the areas that were red before are now covered by at least one test and are green right now, essentially. But you can still see that there are some areas left that remain untested. So here highlighted with these arrows. The first one is functionality that was already prepared for the next release and was not reachable from the UI. Therefore, no need to test it yet. After all, you want to do the release, right? We were right before it. So that can be tested afterwards. The second arrow, this was functionality for a feature that was removed, but this area of the code just was forgotten to be deleted. So essentially that's that code. And can be deleted at some point, probably after the release. Again, time pressure. And the third arrow right here, this is a very well hidden CSV export, which is located in some drop-down context menus. And no one just thought of using that. And so they saw that this actually can be tested. So they did and were able to do the release roughly, I think, 2 weeks after the initially planned one. All right, now the release test or the example I showed you right here in the release test is quite linear. What we see more and more in practice is that companies switch to an agile development process, which means you usually have a few or one main branch where you do a release from every couple of weeks or maybe month. And in parallel, you have many feature branches and bug fix branches. And now the testing is not happening anymore on the main branch every couple of months, but is done on every single bug fix and feature branch itself. So you have a lot of tests in parallel. And therefore, we cannot use the view on the whole system anymore, and we are even not interested in the whole system anymore, but only on the changes that were done in the feature branch we are working on or which we want to test. And that's why we developed issue test caps. So essentially, we take the information from the issue tracker. Right here, you can see a view how it looks in team scale. Where on the left-hand side, we have all the information or some of the information from the issue tracker. So the issue number, the subject, the status, and the assignee. And on the right-hand side, you can see the test gap information team scale calculates for this issue. So the third issue right here, for example, for the third issue, 29% of the methods have not been covered by a test yet. So you probably would want to close those before merging it back to master or main. Of course, this number solely doesn't help, so you can do a drill down as well and go to a tree map where you can see which individual methods have been covered and have especially not been covered yet, and use that to execute more tests. Of course, this issue test gap mechanism needs more information compared to what we had before, and that's on the one hand side, the information from the issue tracker. So TeamScale also connects to your issue tracker, so Jira, Azure DevOps, or GitHub, for example, and reads all the information from that. And to aggregate the changes to these issues, we also need the information which change was made or which commit was made for which change, for which issue. And there, for that, we are using annotations in either the commit messages or the branch name. So you just write the issue number in one of the two. And then with that information, you can do the mapping between commits and therefore changes and your issue tracker. And then you have these aggregated issue test caps. Are there any questions towards or regarding the practical example? Or maybe to the first part. Also happy to answer those if you like. Or any questions or thoughts, doubts?
There are no questions in the chat.
All right. 3 to 1, last chance. All right. Then I'll hand over to my colleague Stefan, who will show you everything you've seen in theory right now in a live demo. Stage is yours, Stefan. Yeah. No, now it works.
Thank you. Then, hello everyone. I'm Stefan. I'm the newest member of the test intelligence teams, helping customers, hopefully like you, to use and set up TeamScale. So we already heard a lot of test script analysis already, and now it's time to see it in action. For this, we need some system under test, and in my demonstration today, it will be a project called DigiBank or Digital Bank, which is an open source digital banking application written in Java. And to do the actual testing, we need to get into TeamScale. So let's do this. You have to log in. And then at first we can see the activity stream. Here you can see all the commits that are happening in repositories which are connected to your TeamScale project. In our case, we already selected the correct project. It's called DigiBank. And on the right side, you can even select different branches of your project. So with just a single click, you can get a good overview over all the different branches in your project. You already selected the correct branch here. So let's go back. And before we dive into testing and test scope analysis, I just want to quickly show you some more features of the TeamScale UI. So findings means you can find static results of static code analysis there. So this is one important part of TeamScale. And another interesting part is the architecture analysis, for example. All right, so this should already suffice. Just a few words, what else we have to offer. But now let's jump right into the test scope analysis. For this, I want to show you the dashboard first of all. So what you can see here is an image which is similar to what you've seen already, what Thomas already showed you. You have all your components, all your methods displayed here, and we use colors to tell you if these changes are already covered or not. So in our case, let's just have a look at the green part over here. Green means the changes have already been covered. So let's go into there. I just clicked on the tile, and then we can open method. And if what we see here is the whole history of the method. So every change is listed here, and you can not only see it by looking at those nodes, but you can even look inside the source code from here. So for example, we have on the compare method tab, we have a view which is similar to a diff view you might already know from your IDE, for example. And there you can see all the changes. Let's go one step back. Let's go back into the method history itself. And in addition to seeing the changes of the code, you can also see the parts of the code which are already covered by tests. So if we look at the source code of the method, we can see lines that have different colors in the background. The red background means that this line has not been covered yet. The green background means that it has been covered, and the blue and white background is basically the same, means that this line is not coverable. So you couldn't even gather coverage data for this. All right, now we know a little bit about how we can look at coverage and how we can explore the method contents. Let's go and look at the issue that we are actually supposed to be testing. For this, I go back into the activity perspective, and from there into the issues. And there you can see a whole list of all the issues that are relevant. And if you want to filter down them even more, you can use filter queries. And obviously, since I'm going to be in the role of a tester in a few minutes. I'm mostly interested in the issues that are assigned to me. So if I click on this filter right here, the list gets smaller, and the ticket that I'm supposed to test today is this one right here. We should prevent deposits smaller than 0. Let's click on the issue. And before we get into the details of the issue, just quickly let me explain the page that you see. You can see all kinds of metadata about the issue. For example, you can see the title. You can see other metadata right here. You can see the description, which is always helpful. You can see the test caps, which we'll get to in a minute. And you can even see all the commits that have been assigned to this issue, or rather linked to the issue. As Thomas already said, it's possible to put some special formatted characters or strings in the commit message. And this allows TeamScale to link commits and issues. In our case, the special format is CR#, and then we have the ticket number. All right, so this is the overview of this issue perspective. Now let's jump into our actual role, which is we should manually test what the developer has already implemented for us. So in our case, we should first of all read the description, obviously. We need to prevent depositing negative amounts to accounts, because this would be equivalent to withdrawal of money. Okay, so now we know what we should test. And before we get into the UI of DigiBank, we quickly have a look at if we still have test gaps, or whether some other test already covered all our changes. So what we can see right here, if we look at the test gap part, one of the tiles is already covered by some other test, but we still have 4 left to go. Sorry, 3 left to go. And so this is what we're going to be doing right now. For this, we just go into our DigiBank application. Let me do this quickly. And what happened right now, in addition to opening the application, a profiler was added. And this profiler is now recording all of the source code that is executed while running our test. As you can see, this is all pretty automated, so it's from my role as a tester, this is not really a big deal. All right, now we can see the UI of DigiBank. We are not really interested in the details of the UI. For us, it's only interesting that we can deposit money. So if we click on deposit, select an account, and then we will just deposit some random negative amount of money. We click submit. And in this case, it was good that we saw the error, because this is actually what we were trying to test. We could not deposit a negative amount of money. So in our case, the test was successful. Now we need to cancel the coverage collection, and we need to send this coverage to TeamScale. So this is what I did when I closed this little script. And as you can see, this also it's possible to automate all of this. So still there's, as a tester, there's not really extra work there. Let's have a quick look at how this would be presented in TeamScale. This last addition to the commit stream, this is our upload that we just did. So the new coverage that has been added to the project. Let's look at the test gaps. So we go back into the issues perspective, back into our ticket. And what we can see right here is there's more green, which is good. The left part, which was green before, is obviously still green. And these two parts, they are additions in coverage. But what we can also see is that the yellow part in the middle seems to be still untested. And if we hover over this, this part, we can see that the method which is uncovered is called withdraw. So still as a tester, for me, it's quite clear that there's something fishy here, because withdrawal of money in a banking application seems to be rather important. But even if I did not understand what the method does, this is a good opportunity for me to just talk to the developer that I noticed something is still missing or is not as I expected, and I could just get the information from a developer which has more insight probably. All right, in our case, it would be my turn to talk to the developer now, since I find this interesting enough to do a retest. And the developer tells me that she found some bug in the code of the withdraw functionality, and she already tried and applied a fix there. So let's see if this worked. Like if the changes of the developer was correct or not. So we do the same thing again. We go back into a digibank application. This is already known to you, but this time we do not want to test depositing. We want to test withdrawal. So this time we click on withdraw. We select an account, and this time I just enter an obscenely low amount of money. I click submit, and now I'm rich. So obviously we just found a bug, which we have to report. But first of all, we need to close the profile again and send the data back to TeamScale. Then we go back to the activity stream. We can see the second coverage which has been uploaded. And if we go back into our issues perspective and inside our issue, we can, even though that we just found a bug, this is important to remember, but in this case, our test gap is closed. So what happened there? The changes, which we were actually not supposed to be testing originally, contained a bug, which we can now report to the developer and they can fix it. So this is really a super interesting point of test gap analysis, that it's pretty easy for us to maybe find bugs that we wouldn't have otherwise. All right, so let's go on in our story. I talked to the developer, and the developer came up with a solution to the fix, and I just want to show you this real quick. In this case, we prepared some script as a replacement for the actual coding work. And if we go back into our commit stream, we can see that TeamScale already found the commit in the repository and uses this new commit and shows us information about it. Now again, I want to show you the test gaps of this issue, and in order to do so, I want to show you a quick shortcut. Since commits and issues are linked, we can also jump to the correct issue by just clicking on the link right here. All right, what happened is the part that was in the middle previously, it jumped to the left, but this is it's not a big deal for us. We just have to make sure that we look at the method name in this case. So what happened? The developer, she worked on a withdraw method and really corrected the mistake. So obviously, in a real world scenario, we would be testing this new change again, but well, you have seen how this is done. We would go into the application and gather new coverage, and then we would see that the test has been the bug has been fixed. All right, so this is the main part of the demo already, and yeah, the main point really in this demo is that it was so easy for us to find this new bug just by using it, just by looking at the test caps. Thank you, and I'm happy to answer any questions you have.
There are no questions in the chat. Are there any other questions on audio?
I think what we didn't show yet, so no question, but what you can do that you can select the different test stages here as well. I think we haven't shown that yet. Maybe you can do that.
Okay, sure. You can, if you do have different sources of test coverage, there's a neat little menu right here, which you can use to select the parts that interest you the most.
Okay, still no questions in the chat.
All right, then let's go back to the slides again. And there you have a short overview of the most important languages that we support in TeamScale, especially the orange colored languages. We have the most knowledge about them. We have the most experience with customer projects. So I hope you find your main language here. All right.
Since there don't seem to be any more questions, I can take over again. Give me 1 second. Hope that's the correct one here. All right. So now you've seen everything in practice. Now I'd like to show you in the last part a study we again did together actually with MunichRE a while ago as well, but after they used task gap analysis for a while, and the study we actually published together at the OOP conference afterwards. So already maybe a little spoiler here to the results. But first of all, what was the situation at MunichRE? Well, as I said, they already used task gap analysis for a while, and then at some point their management changed, and they ask themselves the question, well, is all the effort we are putting into task gap analysis actually worth it? And of course, we are happy to answer this question together with them. So if you remember back at MunichRE, we were in the lucky situation that we already have information from before the usage of task gap analysis, which we can use as comparison here in this study. What's important to remember here is that roughly 50% of the change code remained untested, and that the probability of production bugs is 5 times higher for these untested areas. Now, before we jump into the actual calculation, first, what do we actually want to calculate? Because if we are talking about cost and benefits, the first thing that might come to mind is actually how much money are we saving with task gap analysis? And that's very hard to answer because you need to assign a money value on bugs essentially. And that might be rather straightforward for parts of it, because like you can roughly track the time you need to fix to fix the bug and to test it, and multiply that with the wage of your employees. But that still leaves out some factors. So for example, if the bug causes some downtime in this system, this may have a rippling effect to other systems and affect many users. And it's very, very hard at best to track the time that is lost because of that. And secondly, what's even harder is to measure the loss in trust the users are having with each bug they are facing. And putting a money value on trust is very, very difficult, I find. So we instead wanted to focus on something we can actually meaningfully estimate. And that's how many bugs slip through to production when using test gap analysis and when not using test gap analysis. And in the end, if the difference in these two things is high enough, we can still say test gap analysis is worth it. So first, let's calculate how many bugs slip through without test gap analysis. You know from before that 50, or in the second release, 60% of the changed code areas remained uncovered. In order not to overestimate test gap analysis, we are taking the beneficial value here without test gap analysis, so the 50%. 50% of the code remained untested here, of the changes. So how many bugs are in these 50%? Well, that of course depends on how the bugs are distributed across the system. And so we could assume that there is a uniform distribution of the bugs across the entire system. And of course, that would be an assumption, which can be true, but might not be. In order to validate this, we talked to the developers of this system and asked if they know of any especially error-prone areas, because usually developers know if there is some sort of code that's always breaking, right? They couldn't tell us one, so uniform distribution of the bugs is at least somewhat justified here. So that means in these 50% untested code changes, there are 50% of the bugs for this release. So that's the one part. As I said, we also don't find every single bug with our tests. So there's some test ineffectiveness. And how big this is, to calculate how big this is, we can use this information we have from before again. So the probability of production bugs is 5 times higher in the untested changes compared to the tested changes. So when we have 50% bugs in the untested changes, there's 10% of the bugs in the tested changes left to get this 5 times factor. And which also means that we have a test ineffectiveness of 20% here, because 10% of the bugs slip through in the 50% that we actually tested. So in total, that means 20% test ineffectiveness. That we'll need a little bit later on, this 20% ineffectiveness. So right here, we have 50% bugs in the untested changes, 10% in the tested changes. So overall, 60% of the bugs still remain in the system when not using test gap analysis. That's our comparison value here. So now let's see how this looks for the time when they actually used test gap analysis in practice. And the first thing we need to find out here is how many changes still remain untested despite having TGA in use. And for this, we looked at several systems at MunichRE and found a range between some percent and up to 10%. In order, again, not to overestimate the use of test gap analysis, we took the worst here and assumed 10% remain uncovered. So 10% of the bugs slip through because we don't test these areas. Then we have the 90% that actually get tested. And we know from before we have a 20% test effectiveness. So 20% of the bugs in these 90% of the systems slip through, which means 18% of the bugs of the whole system compared to the whole system. So in total, we have 28% of the bugs that slip through when using test gap analysis. So rounding up again a little bit, we can say that we reduce the production defects by 50%, or there is only half of the bugs that appear in production. And that's a pretty significant drop. And we, and also MunichRE, were quite satisfied with this result. And therefore, we were able to present this together at the OOP conference. Of course, all of what I'm showing you here is calculated with the data from MunichRE. And your contexts are, of course, different. Every context is. So this is also not one-to-one applicable to your scenario. What I can tell, though, is from my 5 years of experience working with test gap analysis now is that many customers, for many customers, we are actually seeing similar values right here. So I'm quite confident that you will get a benefit from test gap analysis too. All right. Do you have any questions regarding this cost-benefit study?
So Thomas, just one question around. So I'm not sure means, but I just want to get it clear. So is there a way, some way we get the code coverage for front end or UI part?
Yes, there are also these coverage profilers for the front end. There are tools to do that. Yes.
Okay. Yeah. Thanks.
So there are no questions in the chat.
All right. Then, if you have any more questions after leaving this meeting, for example, or if you want to show, or if you're very interested in the topic and want to show it to your colleagues, we are very happy to hold this exact workshop at your company for free again. So just get in touch with us, either with the contact data you see here, or by replying on the mail we'll be sending you probably around tomorrow with the recording and the slides. With that, thank you very much for your participation and the questions. We'll stay in this meeting a couple of more minutes. So if you like, you can also ask us some more questions here or hang out a little bit, talk to us. Other than that, we will start the feedback poll now in a second. So we'd highly appreciate if you could give us feedback there. Sorry. And once you leave the meeting, again, there will be a survey with some more questions. Thank you very much for answering us these questions and helping us to improve this workshop in the future. Also, a hint to some more workshops in the future. Both are in German, right at the start. So the first one we'll be having, so my colleague Raphael and Stefan will talk on 6th of March about how to deal or how to get fast feedback despite having very, very large test suites without compromising much on the bugs you'll find. And in our second workshop in the near future, my colleagues Fabi and Johannes will have the workshop you heard today just in German. So if you have colleagues who are more comfortable with German, feel free to let them know. This will be on 10th of April. And with that, the last thing for me to say is goodbye. We were happy that you were here today, and I wish you a great lunch or dinner or whatever time it is, a great rest of the day and a great rest of the week, and hopefully see you soon. Bye.